Wait, sorry. What's your name again?
Kel.
Kel? Okay. And where are we?
We are in ARO, which stands for the Atmospheric Research Observatory.
Okay. And what are you doing?
Right now, I'm doing a measurement for total column ozone. This instrument right here is called Dobson.
Okay.
It was designed in the 1920s. It was built in the 1950s, so it's fairly old.
Yeah.
But it's still a really good indicator for total column ozone. We have another instrument that actually will measure it without doing, manual observations here. But we have the world standard of this instrument in Boulder.
Oh, really? At NOAA, right? I know.
And this instrument is actually so good that the satellites, like NASA and actually NOAA has some satellites as well, they will actually call up Boulder and be like, hey, what'd you guys get for this particular number, so they can calibrate their satellites.
Interesting.
So that's pretty cool.
Yeah, that is pretty cool. And sorry, what's column ozone again? I mean, I know what ozone is.
Have you heard of the ozone layer?
Yes.
So basically, I'm looking from ground level all the way up through the top of the ozone layer to see how much ozone total there is.
Okay, in one set column.
In one column.
Right.
We have another instrument that will measure just the stuff at the ground.
Right.
We actually launched a balloon this morning.
Oh, really?
So we'll say as it's going up, it'll actually tell you how much ozone is in each area. So you can kind of get a cross-section of where the ozone is.
Right.
With this instrument, I can just say, I know there's ozone and this is how much there is. I don't know where in the atmosphere it is.
But you know how much the total volume is.
Exactly.
Right, gotcha.
Exactly. So right now, I'm doing a measurement which actually, I changed the wavelengths because ozone is affected by UVB but not by UVA. So if I can change back and forth between that, I can get a good idea of how much UVA is coming through versus how much UVB, so we can convert that to Dobson units of ozone. Okay. So we can find out how much we have there.
Gotcha.
So I'm just actually about to start this.
And how and what are the various parts of this instrument? Just real quick.
Basically, what happens is the sun comes in and hits this.
Okay.
And then it goes down.
Okay, so that's why you have the window open, because you're getting direct solar rays.
Direct solar, and then it's going down and hitting a mirror, and then it's going through these two dials right here. This is Q2 and this is Q1. They actually change the amount of radiation, so basically it's changing whether it's UVA or UVB.
Right.
And then it's going through a chopper wheel as I'm moving this, and I'm actually measuring the voltage output.
Okay.
And so as long as I keep it right around 0, it can get a good idea of like where in the measurement, because I have these set at right now 74, 75. And that way we can tell sort of what the 0 point is, so we can tell for that particular wavelength how much ozone is there, and then the average between all of the different measurements.
And you check out all the measurements. Right. Cool. And so you're at about 0.
So I'm checking to make sure that I have my sun lined up.
Right, gotcha.
And I close the little door, I hit this, and then I'm watching to go across 0 here. What I have my hands on right now is called an R dial.
Okay.
And that's what I use to keep the measurement right around 0.
Gotcha. Oh, so it's a really fine thing.
And I'm going to switch down and go to the next measurement.
How often do you take these measurements?
At least 3 times a day.
Oh, really? Okay.
And there's actually 6 different measurements I can take. Right now I'm doing a CD, ground quartz plate, which is, when I finish I'll show you what the ground quartz plate is. But I can also do AD ground quartz plate, and then I can do some zeniths. So above your head there's a hatch. So for zenith measurements I'll actually open that, and we're not getting direct sun like I am right now, but I'm getting sort of the amount that's diffuse and scattered.
Do you have a diffuser up there?
Nope, it just opens to the sky.
Okay.
But the sun's not getting high enough, so it's not going to be in my way. So.
Cool.
Have we seen an increase or decrease in ozone over the past few years?
It was decreasing until this year. They actually got some during the ozone depletion period, which is the end of August through early November really. They actually saw an increase this year, which could be a fluke, because the ozone hole is very dependent on the polar winds and the vortex. And this year the vortex winds were very small and the hole kept moving. So it could be that, or it could be that we're actually increasing ozone, so we've done a little bit to help the environment, but until we've got another year or two of data sets, we really can't say.
Interesting.
Based off of one measurement.
Absolutely not.
Cool. Well, thank you for the explanation.
Sure.
Appreciate it. I'll let you get back to your measurements here.